Right, we are continually learning LSA types and then stub types, special area types in OSPF. We are continuing that. Uh, Today we'll be completing the topic. We have two more type of stub special area types called NSSA, which is not so stub area, and then totally not so stub area. These two need to be learned. These two things we have to learn. So we are going to see NSSA first. I told you NSSA is bringing the external network as type 7. Now, type 4 and 5 will be denied. In what circumstances we need to see? Why do we deny 4 and 5 and then allow it as type 7? Are we not having any job? Why are we wasting this time? Why should we deny and then allow? That's a good question, no? So let's try to understand that first. If you see this topology here, this router 2 learns the internet from local as well as from other area. If the cost is 100 here, and if the cost that is coming from R5 is less, which one R2 will use? So let's assume the cost coming from R5 is 50. So R2 will only use this because the cost is 50. Here the cost is 100. But I don't like it. Why I don't like it? If I allow the traffic to go via router 5, my resource, these are all my resource, right? My own resource. They're all consumed too much. If it goes out like this, my resources are less consumed. I do not want to consume. I don't want my resource to be consumed. Already my network is too much packed, congested. It's too much congested. Already it is too much congested. So I want a better exit. And this is the better exit. This is the best exit. I do not want this exit. I want this exit. So what I do is I make this area as a not so stubby area. When I do that, what will happen is this 4 and 5 that is coming will be denied, isn't it? 4 will not come, 5 will not come. So automatically, this 4 and 5 will also be denied. But when I configure not so stubby area, the local 5, local 5, not the remote 5. The local 5, local ASBR, LSA type 5, that will be converted as 7. And it will come in. So my router will use this path. You understood? So this is a use case. You understood not so stub area use case? Whenever you have more than one ASBR, and you do not want to use the other area ASBR, you want to use your local ASBR, you can deny that other area ASBR by denying type 5. For that, you configure not so stub area, so that local type 5 will be converted as type 7. And this will learn as type 7. This will learn as type 7. But when this one send it out, it will send as type 5. We learned that in the previous class. right? This is what we are going to test now. Are you ready, sir? All three routers, R1, R2, and R7, R1, R2, and R3. Are you ready? Shall we see? Okay. So what I'm going to do is I'll go to R3, R1, and R2. I'll delete all the previous configurations of stub. Show run section router OSPF. Okay, there is no stub anyhow. Show IP route OSPF. I see the external. These are all coming from where? Router 3. Router 3 is receiving from home. Router 4 and router 4 will be receiving from router 5. Let us try tracing the route. Trace and see where it goes. It will go to 5 and then it will go out. Sorry. It goes to 5. Hmm. So what we are going to do is we are going to redistribute the RIP routes into OSPF now. All right. So R1, if you see show IP route RIP, through RIP also you are learning these networks. Now I'm going to redistribute this. Okay. Now router OSPF 1 redistribute RIP metric I'm going to say 200. Why, you know? I saw the one which is coming from OSPF has got cost of 20, only 20. All right. Oh, okay. Here, this is all slash 32. Okay, now what I am going to do is I'm going to do one more changes in R11. The mask need to be 32 here. You see, in here I have written 32, but when I configure, I think I didn't do the proper 32 config. Let me go to router RIP. Here, show run interface loopback 0. What mask I give? 32 only. Router RIP, no auto summary. Okay, this was the issue. Now, what I'm expecting is if you go now to router 1 and check, you should not see RIP routes. Let me clear the routing table. Clear IP route star. This is the command to clear the routing table. So it will learn from the beginning. It will relearn every routes. You see, that's the route. I can see RIP route with /16 and OSPF route with /32. So it looks like two different networks. Why it is not? I said don't do auto summarization. It is summarizing because I am using RIP. No, this is confused. Show IP protocol. Hey RIP, are you? Version 2. Router RIP version 2. Very important. Now, if I go to router 1, okay, here also I need to say router RIP. Now, clear IP route star. show IP route RIP. You should not see routes. You see, you don't see routes. Why? Administrative distance of RIP is 120 for this network. From RIP also you are learning, from OSPF also you are learning. Which one it is going to take? It is going to take OSPF. Why? Administrative distance is less. What is the administrative distance of RIP? 120. Now, let us go and change the administrative distance of RIP plus 110. Router RIP AD administrative distance command distance 110. Now, even though the administrative distance is same, but even though administrative distance is same, for RIP I changed to 110. You see, show IP protocol RIP. I changed the administrative distance of RIP as 110, same like OSPF, but still you will not see the route. The reason is why? The cost. So what I'm trying to say is even router 1 is not using this exit. It's not using this exit. It is using this exit because the cost is only 20. Here the cost is 200 for this. Yeah. So what should I do? One more thing, router RIP, redistribute OSPF process ID 1, metric hop conf. This is for the reverse path. Okay. Now, if I trace route now, trace route 150.1.1.1, it will still go to router 5 only. After I configure not so stub area, it will take the local one. Okay, so let us wait for this trace to complete. Okay, there is no, let's configure NSSA, router OSPF 1, area 100, stub. Please understand, sir, we have to configure this on every, so I am configuring stub. NSSA. We need to configure this on every router. Area 100, NSSA. So I have configured on router 3. I have also configured on router 2. And I have also configured on router 1. Now, if you go and check, show IP OSPF database, you should not see type 5, isn't it? You see, there is no type 5. Do you see any type 5 here? You see only type 3. After that, you see type 7. And you see, everything is coming from local. It is nothing from router 5.5.5.5. You understood, sir? Now, if I trace route, earlier when we were tracing route, you saw it was going to router 5, but now it will be just going straight to router 1. That's all. Means router 11. It will go to 106.106.0.11. See? It's going straight to 106.106.0.11. Yeah. Okay. So that's about NSSA. Now let us trace route from router 2 and see how it goes. You don't need to even trace route, you just check the routing table, you will know. If you check the routing table, show IP route for the same network, 150.1.1.1, you can see it is going straight to router 1. It is not going to router 3. And the metric is 200, it is not 20. From it has received. Yeah. Because in router 1, when I redistribute, I say 200, no? You want to see that? Let me show you. Show run section router OSPF. You see, I put 200. RIP is 200. I have redistributed to OSPF. So router 2 learns via OSPF that metric of RIP. Okay. So if you see, there is no route to reach the external network via router 5. You have only RIP routes. This is NSSA. Now, if you check the routing table, show IP route, you also see a lot of IA. Okay, what is this N2? Type 7 pathcast is not added. You know what is E2 now? 2 is same meaning, pathcast not added. Instead of E, instead of type 5, you have N, which is type 7. All right. Now what is next? Next is we are going to do totally not so stub area. Why, you know? I do not want to learn this IA. I don't want to learn. Already I am not learning type 3 and 4. Sorry, I'm not learning type 4 and 5. Now I don't want to learn type 3 also. Instead, I want router 3 to give a default route. Who should give a default route? Router 3. What I need to do is simple. Go to router 3 only. See, already you have NSSA configuration. This should be there on every router. In router 3, additionally, you remove this and additionally you put no summary. That's it. So now what are all the things denied? No summary. Instead, what you will get? Default route. Let's go and check on router 2. Check the database first. Show IP OSPF database. You see, you have route type 1, you have type 2, you have type 3, you see, only a default route. And then type 7. So, check the routing table, show IP route. You see, you got a default route. There is no other IA. So, if you ping 777, which is in another area, do you have a route? But you got a. So, I can still ping. Now, assume these two are ISPs. This is one ISP. This is another ISP. This ISP is having another network, let's say 130.1.1.1. But this ISP is not giving that network. You understand? Now, using the default route, it will go this 130. Let us check that. So I'm going to add 130 to this router, internet router. Internet router 10. Okay, router 10 is on the top right side. Show IP interface brief. It's same. Yeah. Now I'm going to say here 130, 130, 130, 130. This route is not available from the other ISP. And I need to add it in the EIGRP. Show IP protocol 1000. Router EIGRP 1000. Sorry, not 100. router EIGRP 1000, and then I have to say network 130, 130, 130, 130. Now, if you go to router 2 and check the routing table, show IP route 130, you will not find. Do you see? No. But when you trace route, you will be able to trace route. First, let us ping. It will go to router 5 and it will ping. See, you are pinging. But if you trace route, it won't go to router 1, it will go to router 5. For all other internet network, it will go to router 1. Whichever router 1 don't give, it will use the default route and go to the other internet service provider, which is on router 5. In the real, yeah, this is how the real world playing with OSPF is done. Hmm. 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 Okay, you're 100% right. See, for 201, it will go to the local ISP connected in R1. For all those networks that is not available from router 1, it will automatically go to router 5 as a backup. That's a backup ISP for us. You see, it goes to router 1 here. That's all. Goes to router 1 and router 11, finish. Yeah, so we have learned all type of stub, totally stub in the previous class. In this class, not so stub area and totally not so stub area. Not so stub area will not allow 4 and 5, and local 5 will be converted as type 7. Totally not so stub area, will not allow 3, 4, 5, and it will have type 7, 1 and 2. 1, 2, and type 7. Yep, fine. We'll stop.